I welcome everyone to our webinar with SAP Press. So since you are here, you probably know who I am and who SAP Press is, but still I'm going to do a small introduction. My name is Kerem Koseoglu. I have been a professional programmer since 24 years. And I'm also an author with SAP Press. I have a book about object-oriented ABAP. And just while I'm talking about it, I mean, there's going to be a coupon code for my book in this session. SAP Press will share it in the chat box. And in case you want to purchase my book as an attendee, you will get a nice discount. So don't miss it in case you want to get this discount. And this session is going to be recorded and published also later on. In case you have questions, I mean, there's going to be lots of participants, so therefore we are not able to take each question one by one. But please feel free to put your questions into the chat box while I'm explaining and while we are doing the webinar. And our lovely hosts will filter those questions and give me the picked questions so I can answer them. So just put your questions into the chat box. And in case you have, other questions which we wouldn't have time for today, you can send them over to SAP Press later on, so we can maybe answer them via email or maybe do a blog post which consolidates all the answers. I'm not sure yet, but we basically want to, answer questions as much as we can. So that was the introduction. Once again, welcome. I'm super excited to see, so many people here online who are interested in this topic. And here at the right side, you will see, a flow of the things that we are going to go through. And the gray, for me at least, the gray boxes are optional. So it's not the end of the world if we don't have time for the gray boxes. But if I can, I will try to touch every subject that I can. So why are we here today? First, a little background information. I actually, I work as an ABAP programmer or architect or team lead, full-time. But I also do some side jobs, as a team leader. I sometimes have to do code reviews. I sometimes have to do technical checks on codes written by other people. And during those code reviews, I mean, there are some points which I see very often, which could be done maybe in a better way, if you don't mind me saying so. I'm not talking about the ABAP code quality at all. I'm only talking about the architectural concepts, because there are many best practices in the object-oriented world. And I try to explain at least some of them in terms of design patterns in my book with SAP Press. But of course, one book can't explain the entire industry, right? I mean, there are many standards and many pitfalls, many anti-patterns. So therefore, I have written a blog post about some of the maybe most overlooked aspects of object-oriented design. And this blog post has, received a very huge interest from other ABAPers, and people started to send me their, their technical designs, asking what could be better. And people, I started receiving emails from people asking about how should I design my program, how should I design this architecture. So I'm trying to answer them, as much as I can, but obviously I'm only one person, so I can't answer every email, but I try my best. So therefore, we have discussed with SAP Press, and we decided that we could do such a webinar where I try to explain those topics firsthand over real-time examples, which I have seen before in my own code reviews or in my own general programming experience. So that was the introduction part. Now, I think I can, just so everyone knows where we are, I can simply, okay, we have gone over those. Now we are coming to elegant objects. So basically, what is elegant objects? So the topics that I'm going to explain today, including elegant objects, are actually not my own invention. I mean, those are not my opinions. Those are, generally accepted or discussed at least. I mean, best practices which turn out to be very useful. And elegant objects is a concept which I like very much, and which is, one of those best practices, in my opinion, of object-oriented programming. And actually, if you research this topic, there are lots of, subtopics under elegant objects. I mean, I have 3 subtopics here, which I will explain in a minute. But there are like maybe 15 to 20 subtopics actually under elegant objects. So what I picked here are, the most significant parts, which I think would benefit ABAP programmers the most. So the first part, if we go here, says COP means class-oriented programming. So what does it mean? I mean, there's usually a huge confusion in the object-oriented world, which is, I mean, just because we are opening a class and writing our ABAP code into the class does not mean actually that we are doing real object-oriented programming. We need to apply the best practices of object-oriented programming so that we are really reaping the benefits of object-oriented programming. Otherwise, we can just open like, 20 or 30 regular function modules, and they would give you the same result with classes. I mean, you wouldn't have any of the advantages of using classes. So keeping this in mind, what does no class-oriented programming mean? So let's jump to my first slide. So this is an oversimplified class. I mean, I bet that everyone in the session can read UML diagrams, but if not, it's, very simple and obvious. So let's assume that we have a class here. Okay, text message. This is the class's name. It has 3 methods. The first method is set recipients. So we can set phone numbers for our message through here. And we can set our text here through this method. And using this method, we can send the message. So far, so good. I mean, this is very simple. So maybe in the background, we are calling a web service to send an SMS message. Okay. So this looks simple and good. And, many programmers would actually use this class directly in their program. So there's a Z program. So the programmer would directly refer this class from their Z program and call this class directly. And maybe you have like 20 or 30 programs where you need to access the SMS functionality. So it looks like a logical solution to access this class from everywhere you want to send an SMS message. So this is exactly what class-oriented programming is. I mean, if you are referring a class directly from your program or from other classes, this is actually not object-oriented programming. This is class-oriented programming. Why? Because you are fully dependent on this class everywhere, all across the system. So in the future, let's assume that you want to implement another version of this class. Then you have to run a where used list and modify like maybe 25 or 30 programs which are accessing this class. Or a better example, now a new requirement pops up which says, now you need to send either text messages, SMS messages, or WhatsApp messages, for example, in your system. Then each of those programs should be able to send text or WhatsApp messages. Then what do? You do a huge where used list because you are dependent on this class. You must do a huge where used list and modify each and every program, which will have also a send message functionality. So if your programs or other classes are referring your Z classes directly, this is not a best practice. This is class-oriented programming, not object-oriented programming. So what could be done instead? Let me jump here and show you what could be done instead. Instead of opening a text message class directly, first, I open an interface. Here you see it. Okay, maybe this This was too thick, so I have to make it like this to make it more visible to you. Yeah, that's better. So first, I open a phone notification interface, not a class at all. And my public methods will be placed into this interface. Now, and it has the same methods as you see, set recipients, set text, and send. Now to send text messages, I still open my text message class, but this implements my interface. I mean, this doesn't have any further public methods. This simply has to comply with this interface. And then I have a WhatsApp message class. And in this class, I implement the same methods, but this class sends a WhatsApp message instead of a text message. Then I open another class called Notification Factory. So whenever a program wants to send a text message to a phone, they first pass a notification type. Let's assume A means, I mean, through a domain or something, whatever you want. A means text message and B means WhatsApp message. So now every time a program wants to send a message, they, through this factory class, they receive an interface, not the class. And the 20, 30, 40 programs in the system don't even see or rely on this concrete class called text message. Instead, all the functionality functions over this interface. So later on, let's assume that I open a new class. Let's call it X for Telegram messages, for example. For the rest of the system, no other program cares. I mean, if there's a text message class or WhatsApp class or a Telegram class behind this interface, I mean, the client programs don't care because all they have to know is how to interact with this interface. I mean, they don't care if further classes come or go. We only deal with new classes in the factory class, for example. I mean, that's not the only possible design, of course. You can do other design patterns for object creations, which I explain in my book. But the major point is the client programs are dependent on the interface only, not directly to classes. Now, when I depend on classes directly, this is class-oriented programming. But when I access the classes behind an interface, I mean, when I don't touch those classes directly, then it starts to look like real object-oriented programming because now we are able to reap the advantages of object-oriented programming because I don't rely on this class or a specific implementation. Now, those advantages, what are those, you may ask, but we don't have time for that, unfortunately, today, because we have limited time. But I have explained those in the book, so therefore, I will skip this part for now. So, this was no class-oriented programming, as I explained. And the second topic that I want to address is data-oriented programming. Now, I have spent a little time here, but now it's going to be easier to understand the further topics because of that. So, data-oriented programming means that your code is relying on data structures completely to function correctly. So, let's assume that we have a delivery class. Okay, simple enough. I mean, this class represents a delivery. And now I have methods like getHeader, which is supposed to return the delivery header, or getItems, which is supposed to return the delivery items in a specific format, maybe not the entire table, but in a specific format, or getPrevious orders, whatever. I mean, you can imagine anything. However, this no data-oriented programming best practice tells us that data should be evaluated as an intimate part of the class, and class data should ideally not be publicly available. Instead of asking the class for data, you should tell the class to work for you. I mean, don't ask for data. Instead, give the class the task and let it work for you. That's the basic idea. Because if you ask for this class's data, and if you modify this data, those data structures all around the place, whenever your data structure changes, you're in a big trouble, because then you pull a where use list and you find 25 programs who have accessed this data structure. Then you have to, modify or at least test all of those programs after you modify this data structure, and your project management is going to hate you for it because you are going to cost lots of money and test man time, However, if you keep those data structures private to this class and make the class work for you, then a change in this data structure will cause only a minor modification in one class or two. I mean, you don't have to run a system-wide where use list to find out who's gonna be affected by this change. You are probably find one or two classes which you need to modify, and which is much more convenient than modifying like 30 other programs which have used your data structures. So instead of get header, get items, get previous orders, whatever, instead of asking the delivery class for data, now this is a overcomplicated diagram, but it is to show you how it's gonna scale. So first, just like we have learned in the previous step, I have a delivery interface here. You can see it. Instead of asking the delivery data to create an invoice later on, I simply implement a method. Just convert this to an invoice. And then I have an implementing class like normal delivery. Maybe I will have further classes for deliveries, return deliveries, or whatever, but now I call it normal delivery. And then whenever I want to create an invoice, I don't ask for delivery data from my client program. Instead, I tell the delivery class to create an invoice for me. And this delivery class will call the necessary BAPs and whatever, and create the invoice, and then return the invoice to me. This is your invoice number, or even better, this is your invoice interface. This is even better. And now you can tell, you can ask me, why is this delivery caring about, invoice details? Do we really have to implement invoice BAPI details in the delivery class? You don't have to do it, actually. You can have another invoice factory class, which is responsible of generating invoices. And this delivery class can still access this invoice factory, but in no case, I'm not asking this delivery class for its data from the outside. The only place that I'm passing delivery data is happening between those two classes. The invoice factory is asking for some parameters. And when I ask the delivery class to create an invoice, the delivery class is responsible to loop through its internal tables and read its private data structures and convert its data to a format which is expected by the invoice factory. So the only time when I'm passing data between objects is happening through interfaces, not through classes themselves. So the delivery class is responsible of, in some way, prepare this invoice parameter format to create invoices. So let's go one step back. So this is the non-recommended case. I'm asking the delivery class for this data because I have to manipulate it somewhere. Here I'm fully dependent on those delivery data structures, and if I need to change them, I'm in trouble because maybe they are used all around the system. But here, I don't care about the private data that the delivery is holding. I'm simply telling the delivery to create an invoice for me. The delivery is fully responsible of looping through its own data, but this is all an internal progress. So if I add 3 or 5 new fields to my private delivery structure, it would only affect my delivery class, no one else. So I don't have to run a huge where use list and cause a big test overhead or something. So here we basically say we don't want to be reliant on data structures. We would rather, we don't ask for classes for their data. Instead, we tell classes to do the work for us. I mean, of course, there are, reasonable exceptions for every case. I mean, those things are not rules. I mean, if you are not doing this, you are not doing it wrong necessarily. But those are the recommended best practices, and you have to have good reason to break them. I mean, if it's just a simple data holder class, right? I mean, of course, it's okay to ask for this data, but as the classes get more and more complicated, things tend to get worse as you ignore those best practices. And the final point under elegant objects that I want to address is no inheritance. So I don't have a slide for that, but this is discussed all around the place. So I'm not going to go into much depth of it, but basically, when you inherit a class from another class, which means, I mean, you have a class A, and then you inherit another class, which, inherits all of the properties and methods of your former class. This is actually a hidden way to copy code, because we have said that we don't want to, we don't want classes referring each other directly. And we don't want classes to be reliant on concrete classes directly. I mean, instead, we want classes to, interact each other through interfaces. But when you inherit a class from another class, you are creating a very tight one-to-one relation between two classes, which is not good, because then you have trouble when you have to modify one of the classes. So there are different techniques, I mean, to, get rid of inheritance completely. I mean, you can use, I mean, there's a design pattern, which I like very much, which is called servant. I mean, you can find it in the book. And there's also a concept called dependency injection, which in some cases, negates the necessity to inherit classes from each other. So I'm going to talk about them in a short while. But basically, if you are doing inheritance, it means that you are, not doing the best practice, and you are creating a one-to-one relationship between two classes. So this is, most of the time, this is considered as a code smell, which means that there's actually a bigger problem under your architecture. And this is actually most of the time, class inheritance is a technical debt, which means that, I mean, you are finishing your project today in a shorter time, but you are going to have to pay this time cost later on, when the trouble starts. So this is actually most of the time a technical debt. So, I mean, do I not do inheritance? I mean, sometimes I do, and sometimes I have to do, especially if I can't modify, some class because it's a standard class or something. Sometimes I must do inheritance and modify the subclass. But unless it is a necessity, the best practices tell us not to use class inheritance at all. I mean, it should be avoided whenever possible, but there are always exceptions. I mean, this is not a rule. I mean, sometimes you have to do what you have to do, but as a best practice, it should better be avoided. That's the message. So, folks, we have gone over elegant objects, and I recommend reading this topic. I mean, you can find this topic called elegant objects, I mean, online, and I don't necessarily agree with everything explained there. I mean, I don't follow all of the rules, but this is definitely worth reading. I mean, and there are very good, fresh ideas, which would, give you different points of view. So I definitely recommend reading about this subject, and there are lots of, online discussions and resources for this. So our next topic that I want to address is object thinking. Actually, oops, sorry. I will just organizing my notes, and okay, that's better. Yeah, sorry for the interruption. I had a small physical challenge here. Yes. So object thinking is actually nothing new. I mean, this is a concept brought by David West back in the day. And it's a very, actually, this is a book once again, and this is a very long book, and it's a very, philosophical book, to be honest. I mean, I could recommend you to read it, but it's it's not like elegant objects. I mean, elegant objects are easy to read and easy to understand, but object thinking really requires you to, in my opinion, read it in a philosophical way to understand the concepts there. But still, I mean, there are some very good recommendations that I want to bring here to the session, because in my former code reviews, I have many times seen ABAPers, ignoring those principles. I mean, they seem simple, but they are actually very useful because they guide you through. I mean, they force you to create a better architecture, actually. So the first the first principle that I want to address is called real objects, which means each class that you create should have a physical reference in the real world, or at the very least in a cartoon world. I mean, you can imagine a cartoon created by Disney or whatever. I mean, like Tom and Jerry, whatever cartoon you want. I mean, the object that you are creating should have a virtual or imaginary correspondence in a cartoon world, or even better, if possible, it should have a real correspondence in the real world. So what do I mean with that? I mean, no system, limits you from creating classes. You can create a class for everything, or you can create a class called ABC. You can create a class called, polka dot red cats, whatever. I mean, you can create all kinds of classes, but there should be a limit. Otherwise, you start to drown in classes. I mean, you can open 100 classes for a program that you are writing, and you can still find a reason to open class 101. I mean, there is no limits. So this concept, in my opinion, I mean, pushes you towards limiting which number of classes you should create and what kind of classes actually you should create. So this is an example. I mean, this is an example that I've seen all the time in my code reviews. So this here is a class called invoice reader, right? And it has a simple method. I mean, this is actually oversimplified, as you can tell. But anyway, there's a simple method called read invoices, which returns the invoices in a specific format. I mean, this is not a best practice either. But anyway, I mean, I'm just trying to keep things simple here. So this class is actually not a best practice. I mean, despite the fact that it looks good, it's a simple class. I mean, it looks good. The name is understandable, but this is still not a good class. I mean, this object, in my opinion, does not qualify to be a class, to be a citizen of the SAP system, if you want. Why? Because what is an invoice reader? I mean, can you look at the physical world and see something called invoice reader? I can't. I mean, when I look around in an office, in an accounting department of a company, I don't see an invoice reader. I mean, I see invoices. I see a database. Maybe not with. I mean, the database is virtual. You can discuss, but at least it's more real than an invoice reader. I mean, this is too abstract to be a class. I mean, there is no object called invoice reader. So that's why we call this principle as object thinking, right? Object. Is there an object called invoice reader? No. Then this does not qualify to be a class. I mean, now let's skip to the next and see what we could have done instead. Of course, I mean, this is once again too complicated maybe, but a little too complicated. I have made this that way intentionally to show you how it will scale if the system grows. So instead of having, an invoice class and an invoice reader class, I can split this concept into classes which correspond to real objects. For example, my first object is an invoice set, right? I mean, is an invoice set a real object? Yes. When I go to the accounting department and I look at the desk of an accountant, I see piled invoices in the accountant's, basket or desk, whatever. So an invoice set, where is mine? Yeah. So an invoice set is a real object. So it qualifies to be a class, because it corresponds to a real world object. Then An SAP system, right? Does this qualify to be a real object? Yes. Because why? I mean, SAP system can't be touched in the physical world, but still, it's a real object, at least in the virtual world or in my cartoon world, if you want. I mean, I like to call it that way. It has a correspondence because we have a server, we have installed software. So this is, a real object, which we pay for even, and we pay good money for it. So it's better got to be real. Otherwise, I have wasted my money on nothing. But this is just a joke, that it's a real object. So instead of, creating an object called invoice reader, which does not have any physical correspondence, I split this into two sets. And when I want to return, these invoices from the system, here's my interface called invoice repository, right? This is also a real object because maybe part of my invoices are in the SAP system, but I have to use, for some reason, maybe I have to use two different systems. Maybe SAP is my internal and central invoice system, but then maybe I have a marketplace on the internet somewhere. They also have a separate invoice system. So whenever I want to pull invoices from those systems, I will simply access this invoice repository and first pull the invoices from the SAP system, which will return to me an invoice set in form of an interface, preferably, not an internal table. It will return to be an interface. Then I can pull from the whatever system invoices once again, and then I get another set of invoices. See, I mean, instead of making up a non-existing object of invoice reader and whatever, instead of that, I split my classes into other more qualifiable, if that is a word, classes which have real-world correspondence. That's the key. I mean, whenever you are creating an object, not object. Whenever you are creating a class, it should always, but always correspond to a real object in the physical or at least in a virtual world. Otherwise, you have, created a philosophical imaginary object, which is very hard to understand. And this also limits you and in terms of how many classes you are supposed to create. And this also guides you to create a system which is easy to understand by anyone. Maybe a new consultant or a new ABAP programmer comes to your system and they look and try to understand, the system that you have built. Now, if I see a class called invoice reader, this is what invoice? I mean, okay, I can assume that this is an SAP invoice. Okay, obviously, but where does it read from? I mean, is it calling a web service? You know what I mean? I mean, is it reading the database? Is it reading a third-party invoice system? Is it calling the document management system to pull PDF files? I have no idea. I mean, this is too abstract to understand. But here, when I see an invoice set, I can immediately imagine it. Okay, this is a set of invoices from an accountant's desk. When I see a class called SAP system, I can immediately imagine, okay, this class is dealing with the system itself, with the SAP system. And then when I see this whatever system, let's call it system X, whatever, okay, this class is dealing with system X. I mean, it is much easier to understand and deal with. And sometimes you write a code, and after 3 years, you have to go back to your own code, and you don't understand and remember anything, right? I mean, this maybe happened to the best of us, once or twice at least. And this also prevents this embarrassment. I mean, when I go back to my code after 2 years, I can understand it and remember it more easily when each class corresponds to a real world object instead of imaginary objects. So the other principle here is, each class should do only one thing. I mean, this is obvious, and this is probably obvious for most of you, but this is so often overlooked. I mean, for example, I have a class here, example class. This is, again, oversimplified. This is a real world case. I have a class called an order set, and it says, build from database, then display as ALV, and then create deliveries. I mean, oh my God, this is actually an anti-pattern, which I have also explained in my book in more detail. This is an anti-pattern called God object. It means that one object tries to do everything, under the sun. So this is not a best practice. This is, again, an anti-pattern, because then you have too many functionalities in a class, and this is so hard to modify later on, and you can't version those. I mean, maybe you had an ALV grid, then you want to display it as a hierarchical ALV list later on, or maybe you want to implement another way of creating deliveries. Everything is stuck in this simple class, and this is not something that we want. The same applies for methods, actually. I mean, just like each method should do only one thing, each class should also be doing only one thing. So here is, how it could look instead of, stuffing the data reading responsibility, data display responsibility, and creating delivery responsibility into one single class. We can simply split those responsibilities in 3 interfaces. First, here is my order set. This is an interface. I mean, everything should be an interface anyway. I mean, this is a basic thing. When I look at a good class, I expect to see only a constructor and interfaces. That's all. I don't want to see public methods. I don't want to see public data. I mean, of course, there are exceptions. You should always prefer, your common sense over whatever I'm saying today. But unless you have a very good reason to, I mean, whenever I look at a class, I only want to see a constructor and interfaces. That's all in the public section. Everything else should be happening in the private or, the private section of the class. So here I have my order set. And in this class, I will query the database and pull the orders which correspond to my selection criteria. Then, when I want to publish the output, I will go to my order output interface, which has, in my example, 2 implementations. My first order output is an ALV list, which is fine. We all use ALV grids. Then maybe I also want to output my orders as an email. I mean, instead of bloating my order class with a further method called send email, I can simply implement this order output interface as an email class. So therefore, those are, see how beautiful this is. I mean, whenever I need a new output, I only need to implement a new class here. I don't touch my order set. I don't touch my main program. I don't touch anything else. I simply have to implement a new class here. That's all. To create deliveries, I have a further class called here, a further interface here called delivery factory, which can create orders. I have also split this functionality. So, for example, regular deliveries, regular client deliveries, I have a delivery factory class here, which deals with that. And if I need to call my BAPI in a different way to create return deliveries, for example, then I can implement the second method. In that way, I have, scattered the responsibility among classes. So my order set is only responsible of querying the database and pushing data to other interfaces. As you see, I have explained before that data should be intimate. You also see it here. My order class does not publish any data to the outside world. The only time that we exchange data is exchanged through interfaces, not through classes. So therefore, whenever I change something in my orders private section, like an internal table or structure or something, no one else cares. I'm only dealing with here. And as you see, all of the objects here are, more or less have a correspondence in the real world. My ALV grid has a virtual correspondence. An email is a virtual correspondence. An order set is a virtual correspondence. I can go to the sales department and see an order set. You know what I mean? So this is explaining why each class has to do only one thing. Otherwise, you are losing flexibility. And if your class is doing too much, this is a technical debt. You eventually have to pay it. And you eventually have to, repeat the same tests again and again because you need to modify those central classes. Now, when I look at the clock, I'm going to skip this optional gray part. I told you in the beginning, we kind of made a deal. If I'm running out of time, I'm going to skip the gray parts. And now I want to quickly jump to dependency injection so we have times for a couple of questions. So by dependency injection, what do we mean? This is also, not my opinion. I mean, this is a best practice in the programming world again. There's a principle called Hollywood principle, and Hollywood principle says, don't call us, we will call you. So what does it mean? I mean, the dependency injection says, now that we have seen that we always have to rely on interfaces, here's the trick. Okay, I mean, here's the thing which is gonna force you a little bit to think out of the box. This says, never ever create and use the class on the same spot. I mean, creating an object should be done somewhere else, and your created class should be passed to a further class as an interface. You know what I mean? I mean, if in the same method, you are creating the object and you are using the object at the same time, it means that you are not following the practice of dependency injection. Of course, do you have to use dependency injection everywhere? No, I mean, as I said, I mean, many times, it's a matter of common sense. This is not a rule, or this is not, a law or a technical law or something, but this is a best practice. This best practice says, don't create and use the object on the same spot. Create the objects on a higher level, like in your programming, SE 38, for example, then pass the interfaces down. So let's see it in an example, which you will understand much better with an example. Now, let's assume that I have a material set class. Okay, so this class basically stores a list of materials with their maybe stock information, their weight, name, whatever. I mean, now this class has the functionality to send my materials to system X, which may be a non-subsystem. Maybe I have an integration or something. Then send this to system Y, another integration. Then send this to system Z, once again, another integration. Now, this doesn't look good to me. Why? Because I'm creating the object for system X, and I'm calling the method to send the material to system X in the same spot. So this does not comply with dependency injections usage apart principle. So what could be done instead? And this is the last point I'm going to show you. Then I'm going to jump to questions. Here is what's supposed to happen, in my opinion, and based on dependency injection. Now, first, I have an interface. I mean, you will always see interfaces all around the place because this is the best practice. First, you will have an interface called material sets, which has a method called send to system. Now, whatever system is sent here, this interface will accept, because in this interface, and in my, let's assume this is my material class. In my material class, I don't want to care about the remote system. I don't want to care if there's a web service or a RESTful API or SOAP service, whatever is there, or maybe I have to call an RFC for another SAP system. I don't want to care with this stuff in the material world. Therefore, instead of creating this system X and system Y classes in my material class here, this is the Hollywood principle and the usage apart principle in combination. In this material interface, I'm telling, hey, listen, if you send me a material system which complies with this interface, I'm happy to prepare my internal table in the format you want and send to this system. See? Now, in my client program, I will first create an object for this material set, okay? Which, of course, will refer as an interface. I'm not creating the class directly. I mean, but still, in terms of simplicity, let's assume first I'm going to create this material class or object is better word, this material object, and read the materials within. Then, when it's time to send those materials to an external system, then I'm gonna create my system object. I mean, based on the selection screen on my program, I can create an object which refer to the class system X or system Y, system Z, whatever. I mean, this is representing a non-subsystem. And then my material class, just like my material class is referring to the interface, my system class will also refer to my interface. So after creating the objects, I don't have anything to do with concrete classes anymore. And when I want to send the materials to the remote system, I will invoke the send to system method on my material class, and following the Hollywood principle, I will send this system interface to the material method. Do you see the difference? I mean, I'm not creating and using the object in the material class. You know, if I'm doing this, it means that probably something could be a little better, something could be a little flexible. I mean, if you are using dependency injection, then you are supposed to create this object outside and pass it as a parameter to the other class. If you are, this is dependency injection, and it's very useful because it forces you to make a better design with immense flexibility. Because when a new system comes, you should just open a new object called system Z, and now you can pass this to the material class, and you don't have to modify anything else. And this is especially useful. This is my last sentence before the questions. This is especially useful in tests, because if I go back here, when I'm doing a unit test, an ABAP unit test, for example, I can create mock classes out of material system and pass this material system mock classes to my real material class to test the functionality. This is another big advantage of dependency injection. I mean, it's very useful in unit tests. I mean, it's always a discussion. How many ABAPers are writing actually unit tests? I mean, I don't think that anyone writes unit tests for everything, but in those important classes where you feel the urge to write unit tests, this is immensely useful because you can create local mock classes very, very easily and pass to your real objects during your tests, and then assert true, assert false. I mean, those things will function very easily. So unfortunately, because I'm out of time, I have to skip this clean code part completely, which was optional anyway, but you can find it in my blog post. There I have explained this, and this is a more easy topic. So therefore, I did not want to spend too much time with it. That's why I left it out as an optional topic. Now, I would like to turn to our hosts from SAP Press, and maybe they have to, some things to say. And if there are any questions, in the chat box, I would like to hear them and answer them as much as possible. And if your question is not answered, please feel free to contact us. I mean, either SAP Press or me, so we can, do our best to, answer your questions. So, what do we have here, dear hosts? So if you are talking, I'm not hearing you. Maybe you are muted. Yeah, both SAP Press accounts are muted right now. Yeah, now you're unmuted, I suppose.
We're sending the questions over via WhatsApp. If you could take a look there.
Sure. I will check the WhatsApp through my phone and okay, I will read it loud. The question is, you have explained using interfaces as another layer, which is good. I agree. Can we call this layer as a facade, or is this facade layer the difference? Actually, facades is a whole different design pattern, actually. This facade design pattern is about, taking a complicated system and make it easy for, maybe visiting developers. I mean, instead of calling like 5 or 6 methods in a row, or instead of creating many objects before you can do what you have to do in your system, you create a facade class, and you basically let other guest programmers to access your system via this easy class. I mean, of course, a facade class can have an interface and probably should have an interface as well. But other than that, I don't see a one-to-one relationship between those. I mean, facades classes are not necessarily interfaces, and not every interface is like a facade design pattern class, if you want to call it like that. Now, another question. What are the most significant advantages of object-oriented over classic? Yeah, okay. Now, actually, yeah, I don't want to, redirect everyone to my book all the time, but this is a fact. I mean, I have explained this in my book very comprehensively, so I recommend that you should read it if you can. But first of all, you become a more flexible system. I mean, if you implement the object-oriented, best practices correctly, your system becomes hugely flexible. I mean, I see it like that. For example, when you are creating a new computer, you put USB ports on your computer, right? I mean, you don't simply solder your keyboard and mouse to your main board. Instead, you put USB ports, so people can change keyboards and mouses all the time, right? I mean, or people can use any external drive they want. So when you do a good design using interfaces and object-oriented best practices, your system looks like a whole motherboard with many USB ports. So you can plug things in and out as much as you want. And this flexibility actually has a cost correspondence. I mean, we are not implementing those design patterns and best practices just to be cool, it does not have anything to do with it. Instead, it has a real impact on businesses and budgets. I mean, when your architecture is more solid, it means that changes happen all the time, as I have marked here. Your changes in the future cost less development time, less test time, and when you go live, you have a decreased risk of bugs. So this is the most significant part, actually. I mean, you become a much more flexible system without any, with at least reduced risks and future test and development and extension costs. I mean, I would rather see, I mean, when I have to change something and I run a very used list, I would rather see only 2 classes instead of 31 classes or 40 classes. You know what I mean? I mean, so this is the basic advantage. I mean, you become much more flexible, and change requests are being implemented much easier, especially in agile development cultures. This becomes even more apparent because you have to change everything in every sprint. So this flexibility becomes much more apparent if you are doing any kind of agile work, And if you are splitting classes in your design, it means that people can work in parallel. I mean, some ABAPers can work on those classes while other ABAPers work in other classes. So you let people work in parallel, which means that things can get to test much faster, and you get many reusable objects. And those are just a couple of points. I don't want to spend my whole speech with that, but you can find the rest in many online resources as well as in my book. So next question says, are design patterns a must? Actually, no. But design patterns should be considered like tested and proven food recipes. I mean, when you start cooking, you don't want to invent each and every food from the scratch, right? I mean, what tastes good, what does not taste good, how much salt is good, whatever. I mean, most of the time you get a receipt and you learn how to cook and then adapt your own cooking style maybe. So design patterns are like that. I mean, they are like ready cooking recipes. And when you use them and when you understand them, they're useful most of the time, but not all the time. But when you know them, you have more tools in your toolbox. I mean, instead of trying to reinvent the wheel all the time for every requirement that you get tested and proven solutions to very, very typical problems in the software world. Nowadays, I mean, when I see a requirement, I don't even necessarily think about a design pattern. I mean, I'm in a state where I simply look at the problem and I can design it in my head. Sometimes it corresponds to a real, classic design pattern, and sometimes not. Sometimes I invent something myself, and sometimes I combine a couple of design patterns to create something new. But it doesn't mean that you can just make it up. I mean, it's just like music theory. I mean, when you start playing jazz or music in general, first you have to know the theory. I mean, you have to know the rules, the standards, the industry standards that are expected from you. Then you can break the rules. I mean, this is, in my opinion, like that. I mean, it's not right to say that design patterns should be, implemented blindly, but it's also not right to say that design patterns should be ignored and you should just, follow your guts. I think, in my opinion, both extremes are wrong. I think that everyone should know the design patterns, but they should also know where to use them and where to avoid them. I mean, this is important. Design patterns should be evaluated as very valuable elements in your toolbox. I mean, if they are missing, you are probably missing a lot. But just because you know design patterns doesn't mean that you have to apply them everywhere. I mean, there's a time and place for every pattern. And sometimes you have to come up with something very original. So this is my answer. And obviously, in my book, I attempted to, to explain all, or not all, but most of the significant design patterns using SAP's and ABAP technologies. So I think it will be useful for many people. So now we are running out of time. I mean, I think it's a good time to stop because I want to give our host a little time, maybe to explain about this coupon and where can the attendees access this actually workshop later on. I mean, is it going to be on YouTube? Maybe we can explain that a little. And where can people, send their questions if they have, if they did not have the chance to ask the question today? So maybe I will leave the last minutes to you to explain those topics, and then we can finish right on time within an hour. So.
Hello, everyone. This is Asia Walks from SAP Press. Thank you all for joining us today. It was really exciting to see everyone coming in and asking their questions. The book does have a 15% off coupon code available. The code you see in your chat is OOP ABAP. And you can save 15% on the book on our website, sappress.com. The video will be shown probably around next week. We'll be adding it to our YouTube channel. We'll also be sharing it with everyone that has registered for the event, so you can go back and take a look and see if there's anything that you have missed or want to take another look at. And if there are any questions that you haven't had an opportunity to ask, you can always reach out to us at marketing@sappress.com, and then we will send over the questions and try to put them all in a blog post that will be posted later on. So I hope I've answered all of your questions. If there's anything that I've missed, you can just put it right here in the chat. We have about 30 seconds or so left, and I'd be happy to answer any questions. Thank you all for attending.
Yeah, this has also been, an exciting, fun time for me. I mean, because I also have an academic background. I, enjoy teaching a lot, and this is a topic that I'm especially keen of. I mean, I like talking about those subjects, and it's not like I have all the answers. I mean, the programming, maybe as a closure, I can tell, and this was also highlighted in my blog post as well, which was the root of this session. I mean, nothing that I have said today is, a rule set in stone. I mean, each requirement is different and each technical infrastructure is different. So sometimes you can comply with the best practices and sometimes you can't. I mean, for example, sometimes I have to do the following. Sometimes I need a very quick solution because there's a big problem in the system. Then I have to break all the rules and, just make a quick and dirty solution. And later on, I mean, after the fire is settled, when I have more time, I upgrade my solution with a better approach with interfaces and whatnot. This also happens. So always and always, common sense and, the requirement at hand should be considered as, the #1 priority. But meanwhile, every time you ignore a best practice, you are probably causing a technical debt, which should be addressed in the future. So a quick solution today is probably causing pain in the future. So we should always consider this. And that's what best practices are for. I mean, they are tested and proven over time. And they help us, write more quality code. So this could be my closure. So I think that common sense and theoretical best practices should always go hand in hand in a good percentage, let's say. So that's all from me, folks. Thanks for joining. Do you have, Aja, any closing words or statements, or should we just simply say goodbye to everyone?
I think it's time to say goodbye. Thank you, everyone, for joining. Have a great day.
Okay, goodbye, everyone, and see you on the next one, hopefully. See you around.